Hello viewers, in today's class we are going to discuss one important result from differentiation, right? And here we'll prove an important result related to the concept of even function, right? So here we have the statement which is to be proved here, or we have to find the value of f prime of 0. So let us first read out the statement. So the statement goes like this: let fx be an even function, right? And the derivative of f of x at x is equal to 0, it exists, right? Then we have to find the derivative of f of x at x is equal to 0, right? So here we'll see the concept of even function, and then we'll give a general proof for this statement, right? So let us first take a few examples to see what this statement is saying, right? See, suppose we have a function, say f of x is equal to x square, right? Now, if we replace x by minus x, then what will happen? We'll get f of minus x as minus x square, and it is x square, right? So we have again got the same function, that is f of x. So when we have a function that is f of minus x is equal to f of x, then we can say that the function is an even function, right? So this is the property of even function. So here we have f of x is equal to x square, right? Now let us find out the derivative of f of x, right? So f prime of x is 2x, right? Now if we take x is equal to 0, then f prime of 0 is 2 times 0. Here we'll take x is equal to 0, so this is 0, right? So see, let fx be an even function and f prime of 0 exist. Then find f prime of 0, right? So the value of f prime is 0 here, right? So here I will prove that f prime of 0 is equal to 0 for all even functions for all x, right? Belonging to the set of real numbers, right? Let us take another example, right? Suppose we have a function, say f of x is equal to cosine x, right? Now if we replace x by minus x, then what will happen? F of minus x is equal to cosine of minus x, and cos of minus x is simply cos x, because from trigonometry we know that cos of minus theta is equal to cos theta, right? So we have again got f of x. So cosine x is an even function, right? So now let us differentiate fx is equal to cos x. So what we will get? F prime of x is equal to negative of sin x, because the derivative of cos x is minus sin x. Now let us take x is equal to 0 here, right? So what we will get? F prime of 0 is minus sine of 0, and sine of 0 is 0. So we'll get minus 0, that is equal to 0. So again we have got f prime of 0 is equal to 0 for the even function, right? So here we have taken two examples to illustrate the importance of this statement, right? Now we will here prove in a general way that when fx be an even function and f prime of 0 exist, then f prime of 0 is equal to 0, right? So let us prove it. So now here we are given that f of x is an even function. So the first thing is that f of minus x must be equal to f of x, right? Okay, now here we are given that f prime of 0, it exists, right? So from the concept of differentiability, we know that if the derivative exists at some point, say x is equal to a, then the right hand derivative must be equal to the left hand derivative at the given point. And here suppose we have the point x is equal to a, and then we'll take a is equal to 0, right? So here f prime of 0 exists, so it implies that the derivative exists at x is equal to 0 or a is equal to 0. So it implies that the right hand derivative at this point, that is x is equal to a in a general way, and for a particular case we have a is equal to 0, so the right hand derivative must be equal to the left hand derivative. Now the definition of right hand derivative is the limit h tends to 0, and we have f of a plus h minus f of a divided by h, right? And here the left hand derivative, this is the right hand derivative, and the left hand derivative is limit h tends to 0, we have f of a minus h minus f of a divided by minus h, right? So we'll take the help of this equation to arrive at this result, right? So now here a is equal to 0 because we have to find f prime of 0, right? So a is 0. So when we'll take a is equal to 0 in equation number 2, then we'll get limit h tends to 0, f of 0 plus h minus f of 0 divided by h. And here we have limit h tends to 0, f of 0 minus h minus f of 0 divided by minus h, right? Now 0 plus h is h, so we have limit h tends to 0, f of h, and here we have minus f of 0 divided by h, and here we have limit h tends to 0, right? Now see, here we have f of 0 minus h. Now see, f of 0 minus h is equal to f of minus h. And now since f of x is even function, so f of minus x is equal to f of x. So f of minus h must be equal to f of h, right? Due to the property of even function, right? So here we have f of h, and here we have f of 0, and here we have h, and we can take this negative sign in front of the limit notation, right? So now we can take this expression to this side. Now see, this expression and this expression both are same. So when we take this expression to this side, we'll get 2 times of limit h tends to 0, f of h minus f of 0 divided by h is equal to 0, right? Because this limit and this limit, both the expressions are same, and here we have the negative sign. So when we take this expression to the left hand side, we'll get 2 times of limit h tends to 0, f of h minus f of 0 divided by h is equal to 0, right? So now here we'll get now we can easily remove this 2, and we have limit h tends to 0, f of h minus f of 0 divided by h, and this is 0 over 2, that is equal to 0, right? Now at this step, let us see the definition of f prime of x, right? Now see, we know that from the first principle, f prime of x can be written as limit h tends to 0, f of a plus h minus, or here we can write x plus h minus f of a divided by h, right? So here we can take a, right? So f prime of a can be written as this limit, right? This is from the definition of first principle, right? Now if we take a is equal to 0, then see what will happen. So f prime of a, that is equal to f prime of 0, and here we have limit h tends to 0, and we have 0 plus h because we are taking a is equal to 0. So 0 plus h is simply h, and here we have f of 0 divided by h, right? So now see, this limit, that is limit h tends to 0, f of h minus f of 0 divided by h, it appears here, right? So this limit is equal to f prime of 0, right? So when we take the value of this limit as f prime of 0 over here, then we can straight away get f prime of 0 is equal to 0, right? So this is how we can prove this statement, or we can calculate the value of f prime of 0.